Right, so I kind of ran out of time in the last video and I was talking about our boundaries here. So boundaries, we can do the midpoint between an upper class limit and the next successive lower class limit by finding the midpoint between those. So you can add them up and divide by 2, and you can do that with each successive one. Or my preferred method, which is to take two successive ones, and it can be any two in this case because it doesn't matter, because we're going to go about this a little bit differently. We take those and subtract them, so 25 minus 1, or 24 is 1, and then 1 divided by 2, which is 0.5 or a half, right? And then what we do with this is that we can find the boundary over here and the boundary over here with that by adding it to an upper limit and by subtracting it from the lower limits. So what we see here is that the boundary over here is equal to 24.5, which you see is exactly what we got here. And this boundary over here is going to be 16 minus 0.5, which is 15.5. And then this boundary here is 33 plus 0.5. And that makes this 33.5. And we can keep doing that all the way down so that we get 42.5 here and we get 51.5 here. Now what I want you to notice here is that this boundary here and this boundary over here are going to be the same, because notice if you subtract 0.5 from 25, you get 24.5, and that's the same as that one. So this boundary to this boundary and this boundary to this boundary, those now touch if you represent them on a number line, and that's what we want. What we still want, though, is we still want our classes to remain mutually exclusive, meaning that data points could not fall within this class and in this class as well. And the boundaries, by first of all making the classes not have overlap and paying attention to the type of data. We said they were whole numbers, discrete numbers, right? So we said if this next upper limit or lower limit is 25, then the upper limit should be 1 unit below that at 24, making them mutually exclusive. And then the gutter, so to speak, the boundary is halfway between. That boundary can't possibly have any of these data points in it, and therefore we know that these, even though these would touch on a number line, there's no data point that could be at 24.5 that could potentially belong to one boundary or one class and the other at the same time. It's just not going to happen. And then what we can do is, remember I told you that some books and some statisticians will use these to create the classes for a cumulative table. Triola does not use that method, and neither do I. I like the less than method because it really shows the stack up, that idea of less than this number, there are this many data points. Less than this number, there are this many data points. And with using the boundaries, I don't see that as apparent. So these are the types of frequency distributions, and we saw a little bit about how they start showing a shape. Now, really, to start showing a shape, we're going to have to draw a picture from these. And that is what our next section of the chapter is all about. The next section of the chapter is all about histograms. And histograms are made from a relative frequency table. So we're going to take, or a frequency table. Your author, Triola, likes his relative frequency tables. Again, the tie-in to probability there, so no problems with it, but I'm just going to use a plain old frequency table to make mine. This distribution will start showing us the shape more clearly of what we talked about in the last video, right, where most of the purse snatchers are in this range, right? We're going to see that pile up, and in our histogram, they'll pile up that we couldn't have actually seen by just kind of a real glance at this, where we have to start looking at it and thinking critically and logically about the numbers that we're seeing there. So that is what we're going to use these frequency tables or these frequency distributions to do, is to get a better picture of the shape. So I'm going to end this video, and I'm going to start in on the next video talking about histograms.